So the next one, write this. The power consumed in an electric resistor is given by. The power consumed in an electric resistor is given by P is equals to E squared over R watts. The power consumed in an electric resistor is given by P is equals to E squared over R watts, where E is the voltage drop across the resistor in volts, where E is the voltage drop across the resistor, and it is in volts. And R is the resistance of the resistor in ohms. And you've been told R is the resistance. R is the resistance of the resistor, and it is in ohms. You've been told is the voltage drop across the resistors, and they are measuring it in volts, and R is the resistance across the resistor, and they are measuring it in ohms. That's the spelling of ohms. Are we together there? That guy. That thing. So, then you've been told, use partial derivatives to approximate the change in power. Use partial derivatives. Are we together? Use partial derivatives to approximate change in power. Use partial derivatives to approximate change in power. Meaning this is what they want you to approximate, the change in power. Use partial derivatives to approximate the change in power when E increases by 4%. So you'll be told E increases by 4%, and R decreases by, R you've been told decreases by 0.05%. R decreases by 0.05%, comma. If the original values of V and R are, if the original values of E and R are, so the original value of E, you've been told, was 100 volts. And the original value of R, you've been told, is 10 ohms. Ohms is 10 ohms, like that, isn't it? Good. And R is 10 ohms respectively. So that is the old question. So the question is, the power consumed in an electric resistor is given by P is E squared over R watts, where E is the voltage drop across the resistor in volts, and R is the resistance in ohms. Find, use partial derivatives to approximate change in power when E increases by 4%, R decreases by 0.05% if the original values of E and R are 100 volts and 10 ohms respectively, isn't it? Now, what they want is what you make the subject of the rule, isn't it? What do they want? They want change in power, meaning make power the subject of the formula, isn't it? And the power is already the subject of the formula. Are we together? Is that okay? So, power should be a function, in partial derivatives, power should be a function of what is varying. And what is varying, you will be told, isn't it? You'll be told E is increases and R is decreasing. Meaning, E and R are varying. One is increasing and one is, they are the variables, isn't it? So it means power is a function of E and R. So we need the total derivative because it is the total derivative which is going to define a change in something or a rate of change in something. Whichever they want is what you get, isn't it? So what is the total derivative of P? The total derivative of P, dP, meaning we are differentiating P with respect to E, isn't it? Partially, isn't it? So we differentiate P partially with respect to E, then we remain with dE, isn't it? Then it is plus, we are differentiating P partially with respect to R. We are differentiating P partially with respect to R, then we are remaining with the dR. So this is the total derivative, isn't it? So it is from the total derivative is what you get what they want. If they want the rate of change, meaning rate is with respect to time, meaning we divide everything with the dt if we want the rate of change, but we don't need the rate of change. We need change, isn't it? So it means when we need change is denoted by that d which is coming like this, isn't it? So change in power is that, isn't it? So change in power, but here we have dp. So it means where is this d? We substitute with this d. Are you see? Are we together? So anywhere you see this d, you substitute with the d for change. You substitute it with the d for change. So from here you can see this is the change in power, this is the change in E, this is the change in R. Are we together? Are we together? Yes. Good. So from here, you now start by getting this partial, because we want change in P. That is what they want, isn't it? Meaning we must get this partial derivative, we must get this partial derivative. Change in E and change in R will be given. We'll just substitute, isn't it? Are we together? So let us start with the partial derivatives. For this, to get these partial derivatives, we must go back to the original equation, isn't it? So the equation you were told, the power P is given by E squared over R. Why are we doing it like that? Because we want to do differentiation. Are you seeing that? And when we want to do differentiation, it means what is in the numerator, if you bring in the numerator, it becomes -1, isn't it? Are we together? Is that understood? Yes. So we have E squared over R. When you bring R in the numerator, it becomes negative raised to -1. If it was 1 over R squared, then it is just R squared, but you multiply by -1 to show that. So that -1 times 2, it becomes R to -2. Lots of indices, isn't it? That negative implies reciprocal. Are we together? Is that okay? Yes. Good. So, from here, the first one, we want to differentiate P partially with respect to P. We need differentiate P partially with respect to E, meaning only E is a variable. The other things are constant, isn't it? So, if E is only the variable, what do we have? R raised to -1 is a constant, isn't it? So, you differentiate it square, you get 2E, isn't it? 2E times that, you get 2ER raised to -1, isn't it? Good. 2ER raised to -1. You are done with that. Then you move to the next one. We now want to differentiate P partially with respect to R, isn't it? We want to differentiate P partially with respect to, meaning only R is considered a variable, isn't it? So it means this E squared is a constant, isn't it? If you differentiate R raised to -1, what do you get? So it is -1 times the constant. So it is -1 times E, you get -E squared, then you reduce the power of R by 1. -1 minus 1, so you get -2. Are you seeing that? Yes. Yeah, that is where some people normally put 0, but you can see this is -1. If you reduce the power by 1, it becomes -2, isn't it? So you differentiated R raised to -1, meaning E was a constant. So it is just like having ax raised to power n times n, then you reduce the power by 1. Power rule, isn't it? Are we together? So we found the two partial derivatives. So if you take back R in the denominator where it was, this means this is 2E over R to power 1, meaning just over R, because this negative is what means reciprocal, isn't it? Are we together? Then this one is the same as negative E squared over R squared, because this negative only is what implies reciprocal. The power remains the way it is, isn't it? Are we together? Good. The power remains the way it is, because I've seen such problems where somebody is given 1 over root R. Then someone is coming and saying, this is 1 of R raised to power half. This R raised to power half just remains the way it is. You simply put negative to show reciprocal. But somebody is putting now it is now R raised to power. No, you know, the power is the power the way it is, isn't it? The negative is what implies the reciprocal. Silio, are we together there? Good. Now from there, what have you been told? You've been told E is what? You've been told E is 100 and R is 10 ohms, isn't it? So for us to get this, what do we now have? Partial P over partial E is what? Where there is E, you put the value of E. Where there is R, you put the value of R, isn't it? Are we together there? So 2 times E divided by R, 2 times 100 is 200 divided by 10. Use calculator, 20. Then the next one, you differentiate P, partial P with respect to E, with respect to R, the second one. What do you have? The P of partial P over partial R, negative E squared over R squared. Negative E is 100. So what do you have? What do you get? Calculator. Because I'm seeing the laws of indices is what I'm using. Eh? What do you have? E squared over R squared is just E over R, everything squared. 100 over 10. That is 10 squared, 100. Then negative is outside. Negative is not part of E squared, isn't it? So you get negative 100. Isn't it? Good. So we found partial P with respect to E, differentiating P partial with respect to R, we found because we were given the values of E and R. So the next thing is to get change in E, isn't it? So what is the change in the voltage drop? Change in E, you've been told E increases. Increases means positive, isn't it? So it means E is positive 4%. And what is 4%? It's 4 over 100, isn't it? So 4 over 100, that is positive 0.0, positive 0.04. Then you'll be told R decreases. So it means change in R. R decreases means negative, isn't it? Are we together? So R decreases, that is negative 0. So what is negative 0.05% from the calculator? Negative 0.0005, isn't it? We are removing the percentage, because we want to multiply them. This times this plus this times this. Are we together? Okay? So we found everything. We found this, we found this, we found this, we found this. So we can now get the change in power. What is required, isn't it? The change in power. So the change in power is what? Is differentiating P partially with respect to E times that. What did you get to be that? You found it to be negative. You found this to be negative 100. Then it is times change in E. Change in E you found to be positive 0.4. Then it is plus differentiating P partially with respect to R. Where is it? This. You found it to be? No. This one you found to be 20. Senior. P, the partial P over partial E, this you found it to be 20. Then change in E was positive 0.04. Then it is plus partial P over R with respect to R is the negative 100, isn't it? You have to be very keen when you are substituting, okay? That is negative 100. Then change in R you found to be negative 0.0005. So if you perform this operation in the calculator, what do you get? If you perform this operation in the calculator, what do you have? What do you have? .0.85, isn't it? So you see, first thing you can see, it is positive. Then the next thing you do, the equation has expressed these things in terms of percentage, meaning you must also express it in terms of percentage. All the changes were in terms of percent, isn't it? So if you change this into percent, you multiply it by 100%. Are you seeing? So if you multiply this by 100%, what do you get? Positive 85%, isn't it? See, positive means increases. Are you seeing? So it means power increases by 85%. Then you have handled that given problem.